So the first pattern I want you to notice is that we have vertical asymptotes at certain places. How would you find the vertical asymptote if you just looked at the equation? So our first equation was 1 over x. Then we have 1 over x minus 2. Then we have 1 over x squared minus 4. And finally, we have 1 over x minus 3 all squared. Hello?
I was wondering.
Did you notice that we have vertical asymptotes wherever there was a non-permissible value? That's something in common in all four of these. What is a non-permissible value? Something you're not allowed to do. And what are we not allowed to do? You are not allowed to divide by 0. Okay? So in the first one, can you see if x is 0, you divide by 0. In the second one, if x is 2, you would divide by 0. Third one, if x is 2 or minus 2, you divide by 0. And the last one, if x is 3, you would divide by 0. So we have vertical asymptotes at non-permissible values. Okay? The horizontal asymptote are all at y equals 0. And what's happening here is we have to think about the end behavior. What happens when x gets really, really big, either a really big positive number or a really big negative number? Okay? So, can you see in the first one, 1 over x? If x was a huge number, you'd have like 1 over a million. What does that get close to? It gets close to 0. In other words, if the bottom of your function becomes a really, really big number, you will have an asymptote at 0. Now, these are graphs in the Getting Started that normally are introduced in grade 11, but lately, due to the pandemic in the last couple of years, that unit has sort of been not taught as in-depth or missed. So if you've never seen these graphs before, that probably means that you didn't do that in your grade 11 class. Okay? So what we're going to do is we are going to look at some new equations. And this is group 1. Group 1, you've got a bunch of equations. You are going to type them into your calculator, sketch the graphs, and if you see any vertical asymptotes, you're going to write them down. If you see any horizontal asymptotes, you're going to write them down. If it has a non-permissible value, you're going to write that down. So the first thing, the first graph, do you notice ended up like a line? The thing that you might not have noticed on your graph, and I'll get you to add it in, is draw an open circle right there. That open circle happens at -1, -2. You can label it as well. This is going to be something new in this unit. Sometimes graphs have holes in them. This is an example of a graph with a hole. Okay? I needed arrowheads on the end of my graph. This one has no vertical asymptotes, no horizontal asymptotes. And the non-permissible value is at -1. And instead of an asymptote showing up, this graph had a hole. Here are the next 4. I'm going to get you to draw the hole on this one. This one has a hole at -2, -3. And this one has a hole at 2, 4. We are also going to get introduced to diagonal asymptotes in this unit. Sometimes a graph has a diagonal asymptote. All right, here's group 2. Sometimes it's hard for the graph to see where the asymptotes are. The equations are listed there beside. And in this situation, all of our non-permissible values ended up with asymptotes. If we factor them, nothing cancels out. So we had seen that in our last example. If you could factor, for example, this one can factor to x plus 1, x minus 1, and the bottom factors to x plus 2, x minus 2, but none of the factors cancel out and go away. You don't have any holes. Then every non-permissible value ends up being a vertical asymptote. The interesting thing in this one is we have horizontal asymptotes at different values. Okay? So, characteristics. Horizontal and vertical asymptotes. And again, the horizontal asymptote, what you have to imagine is what number does it get to if you're thinking about its end behavior. What happens when x gets really, really big? For example, put in a million. Would you agree that 3 times x, if you put in a million, would be 3 million? And a million minus 1 is really close to a million. And if you took 3 million and divided it by something close to a million, that you would be close to 3. Okay? So when things get big, a shortcut for figuring out the horizontal asymptote is just to look at it. I'm going to show it with a highlighter. Like, oh, I just look at my 3x and my x. I ignore everything else. What's 3x divided by x? 3x divided by x is 3. And that becomes my horizontal asymptote. This one, the highest degree is an x squared.
Hockey Academy
I have an
students,
x squared
please
and
make
an
your
x
way
squared.
to the lobby. Hockey. Semester 2, Hockey Academy students, please make your way to the lobby.
And x squared divided by x squared is just 1. And the last one, my highest thing is an x. And I have a negative 2x over an x. And a negative 2x over an x simplifies to just be a negative 2. That will be our shortcut for figuring out horizontal asymptotes. So the first, group 1, is when you had a parabola on top and a line on the bottom. Something bigger degree-wise on top, smaller on the bottom. Now, we're doing a line over a line, parabola over a parabola, same degree on the top and the bottom. Group 3, what we haven't done yet, is looking at when you have maybe a line over a parabola or a constant over a line. In other words, degree is bigger in your denominator. So the first example, a constant has a degree of 0. An x squared has a degree of 2. We call the degree the highest exponent in the question. A line has a degree of 1. So what happens when you have a degree bigger on the bottom? What characteristics do you have? And here are the last ones. Characteristic is that our horizontal asymptote on these one is always at y equals 0. We're going to add a dotted line on all of these ones. Now you're always going to have a horizontal asymptote at y equals 0. That always happens when the degree is bigger on the bottom. Some of these have vertical asymptotes if they have non-permissible values. Some of them don't have non-permissible values, have no vertical asymptotes. So what we're going to do over the next couple of days is, this is part 2 of this unit, learn each of these groups and how to graph them formally so that you can graph any rational graph possible. Line over line, parabola over parabola, parabola over line, line over parabola, and any combination of lines and parabolas in the top of your fraction and in the bottom of your fraction.